Hi, in this new one-shot video for class 12 board examination of integrals, we are going to discuss indefinite integrals. I have divided this one-shot video into two parts. In first part, we'll discuss indefinite integrals, and then in the next part, we'll go on and discuss the definite integrals part. In order to make your life extremely easy, I will not just discuss the theory based on indefinite integrals. I have divided the problems, PYQs that are asked on this chapter into 7 problem types. I will systematically start with the underlying theory and the technique of that problem type and take PYQs as examples to illustrate it. So without any further delay, let us start with it. The first and the foremost idea is the idea of antiderivative. So what we are saying is, if there is a function whose derivative is nothing but capital Fx, what we are defining is integration of fx with respect to dx will be equal to nothing but fx plus c. This c is known as constant of integration. What is the fundamental idea here? So what we are saying is, let us say that there is a function fx is equal to x square. If I differentiate x square and write f dash of x, it is nothing but 2x. So the concept goes like this: if the differentiation of x square is nothing but 2x, so integration of 2x will be nothing but x square. So this is the underlying logic that we are using, and this is known as antiderivative because the first process was nothing but derivative. So now wherever we are trying to find the integrals, we are trying to guess this function whose differentiation will lead to that integral. Now in case of differentiation, we had this idea of algebra of derivatives. What does that mean? If you have a function u and then v, if they are in sum, if I do differentiation, it will get distributed. So if we have nothing but x square plus sin x, I can write their derivative as nothing but the individual derivative. So this would become nothing but 2x plus cos x. Now if I had difference also, then I could use a similar idea, u dash minus v dash. So dy dx of nothing but x square minus sin x can also be written in the same manner, 2x minus cos x. So there is no problem here. What we are doing is we are directly distributing it and getting with an answer. Now in case of multiplication, we had this idea of product rule. So if you have dy dx of x square sin x, what I can do is I can differentiate the first part, that becomes 2x, and write the same, second as same, and then write the first as same and differentiate the second part. So this is what we have got. And if we have division of 2 and then we do the differentiation, then u dash v minus uv dash by v square. So d by dx of x square by sin x can be written as nothing but differentiation of x square into sin x minus x square into differentiation of sin x divided by whole square of the denominator. This is what we will get. Once we are getting these things, and it is very simple to understand what to apply here because there is an algebra of derivative in place. And that is the reason differentiation is usually considered simpler compared to integration. Now, let us say that if we have to differentiate the sine of x square, then we also have something known as chain rule. We can apply this and get to an answer. So if there is addition, we can distribute. For subtraction, we can also distribute. For multiplication, we have product rule. For division, we have division rule or quotient rule, and for composite functions we have chain rule. So first we need to understand, if I do the same thing with integrals, how will I handle that problem? Because if I understand that, then I get an insight that how to deal with integrals and what is the basic thinking process behind it. So let us say we have two functions which are in addition, like x square plus sin x. So here what I am saying is the same idea of distribution will work out. So I can write this as x square dx sin x dx. And ultimately we'll see that we know integration of each of these, so we'll be able to get an answer. So there is no problem with this first construct. If we have difference also, even in that scenario, we will be able to handle it because it will again get distributed. So here also, when I'm writing subtraction, there is no problem. So these two cases are already sorted out. It is exactly like derivative. Now, if I move towards the third part, what I have is nothing but, if I have nothing but a composite function, sine of x square into 2x dx. So you can see that we have a composite function here. And hence in this case, we'll use a technique that is known as substitution. So what was earlier chain rule has now become substitution. So here we will use technique. We do not have a formula for this, like in case of derivative. In the fourth part, if we have nothing but multiplication and a sin x into x square, and now we want to integrate. So in this case, since there is product, we do not have product rule. Instead of that, we have a technique that is known as by parts. And if we have nothing but division of functions, like 1 upon x into x plus 1 into x plus 2, this kind of a function we have. So here we do not have a technique like quotient rule. Instead, what we have is nothing but partial fraction. So largely you can see that the problem that we are facing in integral can largely be divided into 4 types of basic techniques. One, we can distribute it or split an integral into small parts or standard integrals whom we can integrate and get an answer. So this becomes our first category of problems also and technique also. Second is for composite function, there is substitution. For multiplication or product of functions, we have nothing but by parts. And then for division of functions, not everywhere we'll be able to apply it, but in case of rational polynomials, we have a technique that is known as partial fractions. So largely speaking, when you're solving any question of integrals, you will use either of these techniques or a combo of these techniques to come up with an answer. Now let us see what are the first category of problems that can be based on this. The first category of problems are nothing but in which we are splitting the first technique, distribution technique, in which we are splitting a given integral into standard integrals. If I want to do this, you will want to know what are the standard integrals. So now let us start systematically. So if we have trigonometric function and we have sin x dx, the integral is nothing but minus cos x plus c. This c is very important. Please do not miss it out. Then if you have cos x, then the answer is nothing but sin x plus c. Then third part, if we have tan x, it is nothing but ln sec x. Now if I move further and write the value of integration of cosec x, the answer becomes nothing but ln of cosec x minus cot x mod plus c. And in the fifth case, if I take that for nothing but sec x, it is nothing but ln of sec x plus tan x plus c. And if I take the case of nothing but cot x, it is nothing but ln mod of sin x plus c. This concludes what are nothing but the basic integrals that are based on trigonometry. Now there are 2-3 more ideas corresponding to this that we need to know. Second is nothing but if I take algebraic functions. So if you have nothing but x raised to the power n dx, the answer to this question becomes x raised to the power n plus 1 by n plus 1. If we have nothing but integration of 1 by x dx, so this formula is not valid for n equal to minus 1. If I do that, it becomes ln of mod of x plus c. And ninth, what we have is nothing but integration of e raised to the power x dx. It is nothing but e raised to the power x plus c, and a special case of the same part, a raised to the power x dx. It is nothing but a raised to the power x by ln a. It becomes x log x minus x plus c. These are some important formulas that we are getting from these standard integrals. Now, rest of the formulas we will see when we take that type of problem. If I look into the first problem that was based on this idea that came into 2023, you can see that it talks about simplification and then integration. So this question talks about 5 log of x. So we need to convert it into a standard integral or break it down into standard integral and then do it. First, if I simplify this, it is e raised to the power log of x raised to the power 5. And now we have a property that we can write it here. So this becomes x raised to the power 5 raised to the power log of e to the base e. Number to the same base, log becomes 1. So this becomes x raised to the power 5. So the integration talks about x raised to the power 5 dx. That comes out to be nothing but x raised to the power 5 plus 1 by 5 plus 1 plus c. And that is nothing but B option. If I talk about this 2023 question, again we can break it down into 2 parts. So we can write this as 2 raised to the power x into 2 raised to the power 2 dx. 2 raised to the power 2 is 4, can be taken out of the integral. And this becomes nothing but our standard integral. We can write this as nothing but 2 raised to the power x by ln 2 plus c. Now let us check the options out. So again, what we are getting is nothing but 2 raised to the power x plus 2 by ln 2 plus c. And that is nothing but option C. So that becomes the right answer. You can see that what we are doing is we break it down into standard formulas, and from there we are getting our answers. Now let us move towards next technique of problem solving, or next category of problems, that is problems based on substitution. Now, as I told you earlier, we are going to apply this technique only when we have composite functions involved. So if you have something like f of gx, this is a composite function, then the derivative of the same function. This is only when we are going to apply. So it is applied in the case of composite function. So you can understand it like that. The role that in earlier differentiation chain rule used to play, the same role substitution is going to play in this case. Now if you look into this idea is very simple. Let us say if you have been given sine of x square and then differentiation of whatever function is inside this. So what we are going to do, we are going to put this x square is t. Then this will become twice of dx is equal to dt. Resubstitute the values, so this becomes sine t dt. You can see that the variable here and here needs to be same. Once you have done that, simply integrate using the standard integrals. The answer becomes minus of cos t plus c. And in the last step, replace this t by the substitution that you earlier made. That is cos of x square plus c. Now this is a very standard and very simple technique. Here there are 3 steps. One, to first identify what to substitute. So there are 2 ways to look into it. The first way is basically either you can look into this function f of gx. So if you can identify whose composite function is it, so directly you can put gx equal to, this is one technique. Another technique is if you look into the integral as a whole, then you might also be able to recognize this g dash of x. So sometimes first will work, sometimes second will work. And from here you will be able to identify what to put as gx. So this is usually the first part of the question, or part A of the question. In part B, we will put that equal to t like we did here. And in C, then we will integrate. And in the part D, we are going to resubstitute it. So you can see that in 4 simple steps, we will be able to solve all such questions. Now, if I look into this 2020 problem, again, here it is easy to identify this g dash of x. So you can see that whose differentiation would be 2x. So you can easily say the answer is x square. The first instinct for every student would be to put x square is equal to t. But if you can think a little bit more, it will be slightly more beneficial if I put x square plus 1 equal to t. This would work slightly much better. Why? Because the whole term inside that root sign would be t directly, and this will make our life easy. And it will become slightly more easy if I put instead of t here t cube, because then this root sign will also get removed. So slowly you can move towards more intelligent substitutions in order to get your answers faster. So if you do this, this becomes a 2x dx, that is given in the numerator. This becomes thrice of t square dt. So if I resubstitute it, this becomes 3t square dt. And this becomes nothing but cube root of t cube. Or we can write this as 3t square dt by t. So this t becomes cancelled. And in the next step, we will be able to integrate and get an answer. So answer becomes 3t square by 2 plus c. And in the last step, let us substitute the value of t. So 3 by 2 is fine. T becomes nothing but x square plus 1 raised to the power 1 by 3. So this becomes 2 by 3 plus c. So you can understand this first step, identifying what to substitute, is the most important one, because most of the times a student will face a problem in this. In the B part, it is a substitution and then integration and ultimately resubstitution. So think in terms of these 4 simple steps, and these kind of questions can be done very easily. Now let us move towards next 2022 question. In this question, what they have given is the derivative of this function. What they are asking is nothing but the value of function. You can see that what they are doing is they are using the idea of antiderivative, and they are now talking about antiderivative. So if I integrate both the sides, I will be able to find the value of fx. So this becomes sec raised to the power 4x by cosec raised to the power 4x dx. Now in order to integrate this, now let us write. So this will become 1 by cos. So this becomes cos raised to the power 4x. This becomes sine raised to the power 4x dx. So what is ultimately given to us is nothing but tan raised to the power 4x dx. In order to make our life easier, it will make slightly more sense to write it in such a form that we can distribute this idea into two different integrals. So what you can do here is take this 110 square x. Let us write this like this, and then split it up. So if I split it up, this first 10 square x is fine. The second can be written as nothing but sec square x minus 1 dx. You can see that now because of this, the first term is 10 square x into sec square x and minus integration of 10 square x. In order to, now we have two different integrals. This is first integral, let us call this as I1. This is second integral, let us call this as I2. Let us solve both of these integrals separately and then substitute their value here to get to an answer. So if I do that, let us first write I1. So for getting I1 right, and again, what you can observe here is the value of the f dash of g dash of x part. And from here you can think that if I put 10x equal to t, the differentiation is directly given to us. So if I do so, this becomes sec square x dx is equal to dt. So this becomes a t square dt. And if I simplify, it becomes t cube by 3 plus c. So t cube becomes nothing but 10x raised to the power 3 plus c. Now, this is my I1 part. If I look into my I2 part, it is nothing but integration of 10 square x dx. 10 square x can be in turn written as nothing but sec square x minus 1 dx. And we can now distribute our integral sign. And if I do so, this becomes a 10x minus x plus c. You can see that we have got both the integrals right. This you can see. We have got both the integrals right. And we have used our earlier technique of distributing an integral or splitting an integral into standard forms that we can integrate. Once we have got both of these values, we can resubstitute in the question and see what do we get. The answer of the first part was nothing but, so if I write my I now, was nothing but 10 cube x by 3. And the answer to the second one, we have got nothing else but 10x minus x. These are the two answers that I'm getting. So I can write it down plus c. So now the problem is that this I is nothing but given as nothing but fx. But in this fx, you do not know what is the value of this constant. But for finding that out, they have given the value at pi by 4, that is pi by 4. So if I substitute this, this becomes pi by 4. Tan of pi by 4 will become 1. This also becomes 1 minus pi by 4 plus c. So if I simplify it, the value of c comes out to be nothing but pi by 2 minus 4 by 3. Once you have got this value, our next step is to find the value of fx. We have got the fx. Fx becomes nothing but 10 cube x by 3 plus 10x minus x plus c, and c also we have figured out pi by 2 minus 4 by 3. And this becomes our answer. Now this next problem type is based on quadratic expressions. So now here, before I start this, I would like to tell you some standard substitution we will generally use. So if you have a function that involves 1 plus x square, so the standard substitution would be x equal to tan theta. And this will largely be able to solve our question. We have root of 1 minus x square. In this question, we are going to put x equal to sine theta. We can also put cos theta, there is no problem. And if we have something like x square minus 1, root or something, we can put x is equal to sec theta. So largely speaking, we'll be able to use this substitutions to get the answer of a lot of questions. Now let us take some standard questions whose answer we can figure out. So let us take a very simple quadratic expression. So if I have to find the value of 1 upon 1 plus x square. So what I can do here is, and let us write here a square plus x square in order to make life little bit more simple in future. So if I do this, what I will have to do is I will have to put x equal to nothing but a tan theta. If I do this substitution, and here also when we have written this, we could have written a here, written an a here, and again a here. So you can put that a everywhere. So these are the standard substitution that we have. So once I do this, now what will happen is this dx can be written as nothing but a sec square theta d theta. And if I substitute the value, this becomes a sec square theta d theta. The denominator becomes a square plus a square tan square theta. And if I simplify, 1 by a will come outside. This becomes sec square theta d theta. The denominator also becomes sec square theta d theta. Why? Because 1 plus tan square theta is nothing but sec square theta. And once I simplify this, it becomes 1 by a times theta plus c. So if you look into the final answer, how does the final answer looks like? So if I put the value of theta from here, so from here, if I find the value of theta, it is nothing but tan inverse x by a. So my answer to this question becomes 1 by a tan inverse x plus c. And this is a very important result that we are going to use time and time again. Using similar kind of technique and standard substitutions, we can come up with some standard results that will be time and time again used. So let us write all of those. So if we have this form of 1 by quadratic. So one very important result we have already figured out is a square plus x square dx. And this is nothing but 1 by a tan inverse x by a plus c. Another is if we have nothing but x square minus a square. Then the answer in this case becomes 1 by 2a log of x minus a by x plus a, modulus of this plus c. And now if I go into the root part, so if I write root of a square minus x square, the standard result works out to be nothing but sine inverse x by a plus c. We have 1 by root of x square plus a square dx. And it works out to be nothing but ln of x plus root of x square plus a square. We can also write log here instead of ln plus c. And if you have 1 by root of x square minus a square dx, it becomes log of x plus root of x square minus a square plus c. If I look into this result, the first thing that you should notice is if you have a square plus x square here, so if you have quadratic in the first two expressions, what we are getting is 1 by a and 1 by 2a here. And this is very important because this will not come when we have root sign. So if you look into this root sign, this part is absent. We do not have 1 by a terms. Now in this first case, we have sine inverse x by a. In these two cases, we have x plus root of x square plus a square and x plus root of x. So you can see that this part of the expression that we have written here, that is coming out to be same at both the places. And this is something very interesting to note. Now, if I look into integrals that are in this form root of quadratic, then in order to get this, the method is we will have to use by parts. So what we are going to do is we are going to consider root of a square plus x square as our first term and 1 as our second term. And we are going to apply by parts. So this becomes root of a square plus x square, first function, into integration of second function minus differentiation of first function and then integration of second function. This is what we are going to do, and integration of dx becomes x. So our answer becomes x plus a square plus x square minus, in the second part it becomes 1 by 2 root a square plus x square, and then differentiation becomes 2x. Again what we get is x and then dx. And if I do so, my 2 will get cancelled out. This becomes x times root a square plus x square. And this becomes nothing but x square by root a square plus x square. In order to even things out, I will add and subtract a square. This is my I. And if I simplify it further, this becomes x root a square plus x square. And this I can split into two parts. The first part becomes x square plus a square by root of x square plus a square. This is what we are getting. And the second part becomes plus a square by root x square plus a square dx. So once we are getting this, what we are going to do is this part, if I do, so what we are getting here is a square plus x square is fine. This part, what we can write is nothing but the numerator It will cancel out and become root of x square plus a square dx. The second part, we can take a square common, and this integral we already know. This is nothing but x plus root of x square plus a square. So now you can see that this term has been regenerated. This term is nothing but our I only. And there is one more I waiting here. So we can take it on the other side. Write this as 2i. This becomes x root a square plus x square plus a square ln of x plus root of a square plus x square. So once you have these values from here, we can get the value of I. It becomes x by 2 root of a square x square plus a square by 2 ln of x plus root of x square plus a square plus c. You can see that we have to apply by parts and invisible by part in order to get the integration of this function. Now we can see that this, what we have figured out in this case, we can also do this for root of a square minus x square, and then ultimately root of x square minus a square dx. What is the trick to solving these questions? Is nothing but first, the answer is nothing but x by 2. Write the same function that was given in the question, and then take this a square with sign, so a square by 2, and then integration of this reciprocal, and then it becomes ln of x plus root of x square plus a square plus c. In the second part, we can also do the same, x by 2 root of a square minus x square plus a square by 2 ln of, now here the reciprocal of this will become 1 by a, sorry, sine inverse of x by a. So you can, here we are writing nothing but the integration of reciprocals, and this makes remembering this kind of formulas extremely easy. Otherwise, this much longer expression, most of the students find it very difficult to remember. But if you have this technique into place, write x by 2 into the original function a square with sign, so here it becomes minus a square by 2, and then integration of its reciprocal, so x plus root of x square minus a square plus c. So here we are getting integration of reciprocals. This part we are writing it down as it is given in the question, and then only thing that you need to remember is there is x by 2, x by 2, x by 2, that is same in all the cases. And one last thing, a square will have to consider with sign. So if you remember it in this manner, it is extremely easy to remember and apply. Now let us look into the application of these kind of formulas. So in this first question, it is based on 1 by root of quadratic. So the formula that we should have connected here is root of a square minus x square dx. So if you keep this formula in mind, that is nothing but sine inverse x by, and since there is root, there will be no a. Very easy to remember. So it becomes very easy to apply here. We need to just convert it into this form. So 4 we will take outside. This will become 1 by 2. This becomes root of 9 by 4 minus x square. And now you can see from the direct formula, we can write this as root of a square. So a will become 3 by 2 whole square minus x square. And then we will be able to write we will be directly be able to write sine inverse of x by a. So sine inverse of x by 3 by 2 plus c. This becomes our final answer. Now in this next question, there are two steps involved. First, what we are going to do is we are going to do a substitution. So we are first going to do substitution, convert it into 1 by root of quadratic, apply the formula and get the answer. So in this manner we are going to work it out. So if I use this logic, then 10x is equal to t we should put, because there is sec square x given. So this becomes sec square x dx equal to 10. Most of the time in substitution, you will realize that if I observe the derivative part very clearly, life becomes extremely easy. So if I do this, what I get is nothing but dt here, and this will become a root of t square plus 4. And now the nearest integral that you can remember is 1 by root of x square plus a square. The formula for same was nothing but ln of x plus root of x square plus a square plus c. Just apply this formula and get the answer. So this becomes nothing but integration of dt by a root of t square plus 2 square, and we can write this as ln of t plus root of t square plus 2 commod plus c. And now here t you can put as nothing but 10x. If I put 10x here, I get my final answer. You can see that now we have connected both the ideas that we learned earlier, the idea of basic substitution and then the idea of quadratic. Now if I move to this 2017 question, this talks about a quadratic in the denominator. So what we can do in this question, we'll have to make a perfect square out of it. So what we can do in the first step is 5 is fine. We can take this minus sign common. It becomes 8x plus x square. Now the standard process of making a perfect square is we want to generate a square plus 2ab plus b square. So what we can do from here is a square is already x square. We can write 2 into x and then there is 4 remaining here. Since 4 is remaining, we need to add the square and subtract the square of 4. In this process, we were able to generate a plus b whole square or x plus 4 whole square minus 16. Let us substitute this value, and if I do so, this becomes dx by 5 minus x plus 4 whole square minus 16. And if I do so, next step becomes extremely easy. We can write this as dx by 5 minus x plus 4 whole square plus 16. And this becomes dx by, this becomes nothing but 21 minus x plus 4 whole square. And once we have done this, now it is in the form of dx by a square minus x square. So this we can write as root of 21 whole square minus x plus 4 whole square. So after this we can apply the formula 1 by 2 times a here is nothing but 21 and log of x plus 14 plus root 21 by x plus 14 minus root 21 come out plus c. Now in this next question, we can see that there is a quadratic present in the numerator and a quadratic present in the denominator. So in such questions, the idea is first we need to reduce it, break it down and then solve this question. So what we are going to do is we are going to take this numerator and divide it by denominator because we need to convert it into a proper fraction. So if I do so, I will have to write 1 here. And this becomes x square plus 6x plus 12 minus becomes nothing but minus 6x minus 2. If I want to write it down, it can be rewritten as nothing but 2x square plus 6x plus 12 minus 6x plus 12 by x square plus 6x plus 12 dx. And once you have it, now what we can do is we can split it into two different integrals. The first one is x square plus 6x plus 12 by x square plus 6x plus 12 dx. And then minus of integration of 6x plus 12 divided by x square plus 6x plus 12 dx. Now once you have this, you can see that this first part is very simple because it becomes 1. The answer becomes x. And this second part, we have a technique to do this. So what we can do in this next part is, in order to do this integral, let us say that this integral is nothing but I1. So what we can do is, if I write 6x plus 12 as nothing but a times derivative of denominator, that is x square plus 6x plus 12 plus b, we will be able to integrate it. So the technique is very simple. You differentiate this, it becomes 2x plus 6 plus b, and this becomes 6x plus 12. Now either we can compare and find the value of a and b, or we can substitute the value. So what I can do here is basically I can put the value of x as nothing but minus 3. And if I do so, what am I getting here? So this becomes nothing but minus 18 plus 12 is equal to b. So the value of b comes out to be nothing but minus 6. And then if I want to find the value of a, I can compare the coefficients. If I compare coefficient of x both the sides. And either I can compare or I can put some other value of x, that is also fine. If I do so, what will happen is, on the left hand side the coefficient of x is nothing but 6, on the right hand side it is 2a. So the value of a again comes out to be nothing but 3. So you've got the value of a and b. Next steps are very simple. So what we are going to do next is, we are going to rewrite this integral. So if I rewrite this integral, it can be written as a into integration of the differentiation of denominator, and then let us also put the value of a here. This a would be nothing but 3, and then plus we have b, that is minus 6 into dx by x square plus 6x plus 2. Now again it gets converted into two integrals that can be done. In this first integral, we can put this denominator as t, and then the derivative is given in the numerator. So there is also a shortcut regarding this. The shortcut goes like this: if we have f dash of x by fx dx, the answer is nothing but log of fx plus c. This we can do. If I apply this concept here, the answer to the first part becomes 3 times log of x square plus 6x plus 12. And for the second part, what we can do is minus 6 times integration of dx by x plus 3 whole square plus 3. And now we can apply the formula for 1 upon x square plus a square, that is nothing but 1 by a tan inverse of x by a. Once we have got the answer to this question. So let us go back again. So look into this question. There are two very important steps. In the first step, we divided it and figured out that there are two parts in the numerator. If I divide the first part, I get the answer to the first part, that is nothing but x. In the second part, there is a linear by quadratic format. This is linear by quadratic, and the method to solve this is very simple. We write the linear part here into a times derivative of quadratic plus b. Compare the coefficients or put the value of x to get the value of a and b. Once you have figured that out, we can solve this integral very simply. You can see that the first part was nothing but x minus, let us correct it, and then we have the second part. Here also we'll get a minus sign, and we can see that this becomes nothing but x minus in the next step, and here it becomes plus. Also let me correct it here, minus and plus. So once I write it down, what will I get is nothing but, in the first part it is nothing but a function, and in the denominator is nothing but whose derivative is written in the numerator. So it is f dash by fx form. We can integrate and find the value. In the second part, this is dx by root of quadratic, and for that we can make a perfect square here, apply the formula and get the answer. Now in this 2019 question, we have a very specific format of linear by quadratic. For solving such questions, what we do is, the first step, we are going to write linear into a d by dx of quadratic plus b. So if I do it so, this is 3x plus 5 is equal to a times 2x plus 3 plus b. Now in order to find, what we are going to do is, we are going to compare the coefficients or put the value of x. I am going to compare the coefficients. So if I write the coefficient of x on the left hand side, it is 2a, and the constant term is 3a plus b. So if I compare, 3 is equal to 2a. So the value of a will be nothing but 3 by 2. If I compare the next part, 3a plus b is equal to 5. And if I put the value here, it is 9 by 2 plus 5 is equal to 5. So if I do so, it becomes nothing but 1 by 2. So we have got the value of a and b in the first part. If I move forward in the next step, what we are going to do here is, we are going to put the values. So a is nothing but 3 by 2, and derivative of denominator, that is 2x plus 3 by x square plus 3x minus 18. And the second part becomes nothing but plus 1 by 2 integration of dx by x square plus 3x minus 18. Once you have got both of these values, now you can see here that there is derivative differentiation. So a very simple result goes like this. If we have f dash of x by fx dx, the answer is going to be ln of fx plus c, and this you can do by very simple substitution. So I'm going to use this result here. This becomes 3 by 2 log of x square plus 3x minus 18. And then there is this second part. In order to solve this, let us write this as I dash. If I want to solve this integral, let us write it separately. So the value in the third part of this integral is nothing but dx by x square plus 3x minus 18. So in order to solve this, we are going to generate a perfect square. So we can write dx here. X square is fine. 2 into x, 3 by 2. And then you will have to add 3 by 2 whole square and then subtract 3 by 2 whole square. If I do so, the value that it generates is nothing but x plus 3 by 2 whole square minus 9 by 4, or 3 by 2 whole square. There is no problem in this. And we have got our standard form. So this is the integral that we already know. If you have integral of dx by x square minus a square, the value is nothing but 1 by 2a log of x minus a by x plus a comma. We can use this formula here again. So the answer of I dash that we wanted to form has now become 1 by 2 times 3 by 2 and log of x plus 3 by 2 minus 3 by 2 by x plus 3 by 2 plus 3 by 2. And if I simplify this, I get my answer. So answer to this question becomes nothing but 1 by 3 and then log of x by x plus 3 plus c. We put the value and we get the value of I. So the value of I, or the original integral, becomes nothing but a, that was nothing but 3 by 2 log of x square plus 3x minus 18 and plus 1 by 2 into 1 by 3 log of x by x plus 3 mod plus c. This is the answer we are getting. You can see that there are three distinct parts of the question. First is this very important idea of linear is equal to a times derivative of quadratic plus b, getting the value of a and b from here. In the second part, we divide this into two different integrals. The first one is very simple to find. For the second one, it is 1 by root of 1 by quadratic. For here, you can see that we have generated a perfect square. And once you have got the perfect square, we apply this standard formula and come up with an answer. So it is not a very difficult question. What you can check is you can check my calculation if I have got something wrong. If I look into this 2014 question, it talks about linear by root of quadratic. So what I can do is I can use a similar technique. Linear is equal to a times derivative of quadratic plus b. So if I apply this, my linear is nothing but x plus 2. And my quadratic part is nothing but x square plus 5x plus 6 plus b. So if I simplify this, I get a into 2x plus 5 plus b. And this is nothing but equal to x plus 2. Now what I can do is I can compare the coefficients, so put the value of x. So if I compare the coefficient, it is nothing but 2ax plus 5a plus b. If I compare the coefficient of x, it is nothing but 2a will be equal to 1. So the value of a comes out to be 1 by 2. And if I do it for the constant term, 2a is equal to 5a plus b. 2 is equal to 5 by 2 plus b. Or the value of b comes out to be nothing but minus 1 by 2. So we have got the value of a and b. In the next step, we are going to rewrite the numerator as nothing but a. So if I write a, it is 1 by 2. And the differentiation of denominator is nothing but 2x plus 5 by root of x square plus by 5x plus 6 dx, and plus b, that is nothing but minus 1 by 2 integration of dx by root of x square plus 5x plus 6. This we need to find. So you can see that now we have got two integrals. This is integral 1, this is integral 2. Let us call this as I1, let us call this as I2. Let us find the value and substitute it. So if I take my I1, it is nothing but 1 by 2 times 2x plus 5 dx by root of x square plus 5x plus 6. So what we can do is we can put x square plus 5x plus 6 as nothing but t. So twice of x plus 5 dx will be equal to dt. And once I substitute this value, this becomes 1 by 2 dt by root of t. And this can be written as 1 by 2 times t raised to the power minus 1 by 2 plus 1 by minus 1 by 2 plus 1 plus c. And you can see that the answer to this first part becomes nothing but t raised to the root plus c. And this becomes nothing but x square plus 5x plus 6 ka root. This is what we are getting for the first part. If I do my integral for the second part, that is I2, the integral there is nothing but minus 1 by 2 times integration of dx by root of x square plus 5x plus 6. Now this is nothing but root of quadratic, and the method is very simple. We need to make a perfect square in the denominator. So that can be done. X square is there. We can write this as 2 into x into 5 by 2. So then we'll have to add 5 by 2 whole square, subtract 5 by 2 whole square. And then we have a 6 waiting for us. And if I do so, this becomes dx by root of x plus 5 by 2 whole square. And this part, if I simplify, it is nothing but 25 by 4. And if I simplify this, this comes out to be nothing but minus 1 by 4. And if I do so, this is minus 1 by 2 square. And this is again a straightforward integral. If I simplify and write the answer, it becomes ln of x plus 5 by 2 plus root of x plus 5 by 2 whole square minus 1 by 2 whole square. And this is the answer. So we have used here the formula that if we have been given integration of 1 by root of x square minus a square, the formula is nothing but log of x plus root of x square minus a square. Now we can put I1 and I2 in the earlier expression and get the answer. So again, let us go back to the process. So what we did was basically, again, we wrote linear as nothing but a times differentiation of quadratic plus b. Compared the coefficient to find the value of a and b. Once we have done this, we have rewrote the numerator part. And we got two integrals. I1 is nothing but, again, the derivative is given here. So we took that as t. And after that, we simplified and got the answer. For the second part, it is 1 by root of quadratic. We generated a perfect square here. And after doing so, we have applied the formula and got the answer. Now, if I look into this next question, this is nothing but of the form wherein we have linear and then this is root of quadratic. This kind of a form. So how do we solve such questions? So the method is we can write this x plus 3 or the linear part as nothing but a times a derivative of quadratic. So linear is nothing but a times derivative of quadratic plus b. This is the logic or the method to solve such questions. So if I write the quadratic here, it is nothing but 3 minus 4x minus x square plus b. And if you simplify this, this is nothing but this comes out to be a times minus 4 minus 2x plus b. If I simplify, it is nothing but minus 2ax plus minus 4a plus b. And if I compare the coefficients, 1 will be equal to minus 2a, or the value of a becomes nothing but minus 1 by 2. And if I do it for the constant part, it becomes 3 is equal to minus 4a plus b. If I put the value of a here, it becomes nothing but plus 2 plus b, or the value of b comes out to be nothing but 1. Now once you have figured out the value, the second part is to write this simplification and get to the answer. So in the second part, I can split this x plus 3 into 2 part. I can write this as a, that is nothing but minus 1 by 2 into. I'm writing this a as nothing but derivative of denominator, that is nothing but minus 4 minus 2x plus b, and b is nothing but 1. And then we have this quadratic 3 minus 4x minus x squared dx. So now what we can do after this step is we can split that into two integrals. The first one can be written as nothing but minus 1 by 2 integration of minus 4 minus 2x into root of 3 minus 4x minus x square. And another integral that can be written as nothing but plus integration of root of 3 minus 4x minus x squared dx. So we can see that we have divided the integral into two parts. Let us call this first integral as nothing but integral I1. And this part that is written here, let us call this as integral I2. So this is I1 and this is I2. And now we will solve this separately in the third part. So in the third part, if I take I1, it becomes nothing but integration of minus 4 minus 2x root of 3 minus 4x minus x squared dx. So what I can do is this that is written here in the root, this quadratic I can put as t. So 3 minus 4x minus x squared, if I take this as t, this becomes nothing but minus 4 minus 2x dx is equal to dt. And if I do so, this becomes a root of t dt. And now this can be integrated and written as t raised to the power 3 by 2 by 3 by 2 plus c. So my answer to this part comes as nothing but 3 minus 4x minus x square raised to the power 3 by 2 by 3 by 2. Now if I want to find the value of I2, we can see that it is nothing but integration of 1 by root of quadratic, root of 3 minus 4x minus x square. Now in order to integrate this, the step is very simple. We need to take 2 common out from here, and to make the coefficient of x square is 1. So that becomes root 2. And after that we are left with 2 minus x minus of x square dx. Now what we can do here is we can take minus sign common. So this is nothing but x square plus x. And now we can add and subtract 1 and 1 by 4 to create a perfect square out of it. So this becomes a root 2 integration of 2 plus 1 by 4 minus x plus 1 by 2 whole square. And now since we have got this, in the next step we can write the answer, because the formula for this is nothing but x by 2, that is x plus 1 by 2 by 2 root of, this expression can be written as 2 minus x square after simplification plus a square by 2. In this case, this is nothing but a square. So this becomes 4 into 2, 9 by 4. And sine inverse of x by a, that is x plus 1 by 2 by 9 by 3 by 2 plus. So now we have got the value of I1 and I2. We can resubstitute this value in the earlier integral and get the answer. So in the last or the fourth step, we are going to find I by writing it as nothing but minus 3 by 4 I1 plus minus 5 by 4 I2. Let us resubstitute the value here and get the answer. So we have figured out that the first part came out to be nothing but 2 by 3 into 4 minus 2x minus 2x square raised to the power 3 by 2. And then the next part came out to be nothing but minus 5 by 4 into x plus 1 by 2 by 2 root of 2 minus x minus 2x square plus 9 by 4 sine inverse of x plus 1 by 2 by 3 by 2 plus c. This we have figured out, and this is how we get the answer. You can see that there are 4 parts of the question. The first part is to write it as nothing but linear is equal to a times derivative of quadratic plus b. Put this value, figure out the value of a and b. We have done that. In the next part, what we did was basically split this integral into 2 different integrals. Solve the first one as we have f dash of x into root of quadratic. Get the answer. Solve the second one as root of quadratic by generating perfect square. Get the answer, substitute in the original integral and get the final answer. Now in this next question, what we need to do is we need to divide this in the first step, this x square by x square minus 3x plus 1 by whatever quadratic is in the denominator. So I can write this as minus x square plus 1. And now if I divide, I will have to put minus 1 here. It becomes plus x square minus 1 minus plus. So our answer becomes nothing but minus 3x plus 2. Now if I look into the next step, it is nothing but, let us write the numerator. So that is nothing but minus x square minus 3x plus 1 can be written as quotient, that is minus 1, into divisor, that is minus x square plus 1, plus remainder, that is nothing but minus 3x plus 2. So this is what we have. Now if I divide this by nothing but denominator, that is 1 minus x square. Let us see what do we get. So we get our integral, and now if I integrate, you can see that my integral is now split into 2 parts. The first part is nothing but, if I take this minus common, this and this will get divided and will become root of 1 minus x square dx. This is my first integral. And the second part of the integral can be written as nothing but minus 3x plus 2 by root of 1 minus x square dx. So the first one, what we have a direct formula. So this can be written as nothing but x by 2 root of 1 minus x square plus 1 by 2 sine inverse x. This is the answer. This is a direct formula based question. But if I want to do, let us write this as I dash. And for solving I dash, let us follow a very simple method. So now what we will do for finding I dash is, you are going to put the numerator. The linear part is nothing but a plus d by dx of denominator, not just the denominator, the quadratic in the denominator, plus another constant b. This is what we are going to do. And if I simplify this, this becomes minus 2x into a plus b. And if I compare the coefficients, what I can see is minus 3 should be equal to minus 2a. From here, the value of a comes out to be 3 by 2. And the value of b, if I check out from here, comes out to be nothing but 2. So if I want to solve this integral, it is not a very difficult thing to do. Our integral is now again split into I dash, that is nothing but minus 3x plus 2 by root of 1 minus x square dx. If I want to write it down, I will be able to write it down in terms of 2 integrals. One is this 3 by 2 times integration of nothing but differentiation of nothing but 1 minus x square. So that is minus 2x dx by root of 1 minus x square. And the second part, that is nothing but 2 times dx by root of 1 minus x square. Now both of these integrals are integrable, because in the first one, what we can see is whatever is inside this root, that derivative is given here. So if I want to do, I can write one step also, but directly it can be written as, if I put this as t, this will become root t, and integration will become root of 1 minus x square raised to the power 3 by 2 by 3 by 2, and this will become 2 sine inverse x plus. Once you have got the value, let us put it here. And if I put it here, I had first part as x by 2 root of 1 minus x square plus half of sine inverse x. And now we have got the other part of the puzzle from above, and we can see that it comes out to be nothing but 1 minus x square raised to the power 3 by 2 plus 2 sine inverse x. Plus we can further simplify and get the answer. Now, this next question combines the idea of substitution along with quadratic or root of quadratic that we are looking earlier. So, what we can do in this question is we can simply put e raised to the power x is t, and as a result, e raised to the power x dx will be equal to dt. Now, your integral changes to dt divided by root of 5 minus 4t minus t square, and this is root of quadratic standard. So if I generate the perfect square for 5, let us do it separately and then substitute 4t minus t square. A simple technique is to take this minus sign common, and in this bracket what we can do is we can just add and subtract 4. So if I do that, this becomes 5 minus t plus 2 whole square plus 4, and the answer becomes nothing but 9 minus t plus 2 whole square. So this is the perfect square that I'm getting because that is the standard method to do such questions. And now if I do that, this becomes dt by root of 9 minus t plus 2 whole square. If you want to do it very linearly, you can put t plus 2 as t and then apply the formula. If you want to write a long answer, then you will have to probably do this. One more step, differentiate, it becomes dv. And if you put it, this becomes dv by root of 9 minus v square. So answer becomes nothing but sine inverse of v by 3 plus c. And if I put the value of v, it is nothing but t plus 2 by 3. And if I put the value of t here, and it is nothing but e raised to the power x. So my final answer looks something like this, sine inverse of e raised to the power x plus 2 by 3 plus c. Now the next problem type is nothing but problems based on biparts. Now biparts is used one in the context when there is a product of the function given inside the integral. And usually what you will observe is both of these functions are different. There are different functions involved. This is a hint to apply this kind of a concept. Now when this is given, what is the logic? So the formula is nothing but u integration of v dx minus integration of u dash integration of v dx. Now there are 3-4 concepts around which different kinds of questions are formed. Let us see all of those concepts in the form of questions. In this 2022 questions, a by part we have to apply because you can see both the functions are different. And here, in order to choose what is the first function, what is the second function, we will use Eilert rule. And if I give you a very brief introduction or recap of this rule, it is nothing but ILATE. I would mean inverse trigonometric, L would mean logarithmic, A would mean algebraic, T would mean trigonometric, and E would mean exponential. So now in this order we need to choose. Like for example, here this function is algebraic and here it is nothing but logarithmic. You can see that the logarithmic function is above algebraic function. So what we will do is first function we will choose as this and second function would be chosen as this. So this is how we choose first and second function using Eilert rule. So once you have done that, now we will write this as first function into integration of second function minus integration of differentiation of first function into integration of second function. This is the basic formula. So it is like a statement. First function into integration of second function minus integration of differentiation of first function into integration of second function. Like this you can do. So once you have done that, this becomes nothing but log x into x raised to the power 5 by 5. This differentiation would become 1 by x. This will become x raised to the power 5 by 5 dx. Now you can see that this x and this will get cancelled out. And again, you can integrate the second part and get the answer. And if I do so, it will become 1 by 5 into x raised to the power 5 by 5 plus c. You can write 1 or 2 more steps explaining the same steps in much more detail. So it becomes x raised to the power 5 by 25 plus c. It is quite a simple question if you understand the Eilert rule. Let us go over the rule once more. What I am seeing is different kind of functions are involved. If logarithmic function is coming and algebraic function is coming, what we are saying is that the ones that comes first will be considered as first function, which the ones which come next is going to be considered as second function. One more similar kind of question was asked in 2023. In this question, if you see, we will again consider the Eilert rule, and based on what we did earlier, this will become our first function, this will become our second function. So let us write first function into integration of second function minus integration of differentiation of first function into integration of second function. So if you do this, this becomes nothing but x cubed by 3 log of x square plus 1. This will become 1 by x square, 1 plus x square. This will become 2x. This will become x raised to the power 3 by 3 dx. Once you have got this, we can simplify, and this becomes x raised to the power 3 by 3 log of 1 plus x square, and this will become 2 by 3 x raised to the power 4 by 1 plus x square dx. Now there is a trick, you can add subtract 1 also, but I will give you larger method that will always help you solve question. Always take this higher powered numerator and not divide by denominator. So if I do that, if I take x raised to the power 4 here and divide by 1 plus x square, here it will be x square. This becomes x raised to the power 4 plus x square minus minus. Becomes nothing but minus x square. Becomes minus 1. And this becomes minus x square minus 1. And this becomes 1. So now if I simplify and write this down, and let us see what am I getting. So this becomes nothing but x cubed by 3 log of 1 plus x square minus 2 by 3. And now we can split this into two parts. We can write this as x square minus 1, x square plus 1 plus 1 by nothing but x square plus 1. Now you can see that this next part can also be split into two integrals. You can see that the first becomes nothing but x square minus 1 into x square plus 1 by x square plus 1. And the second becomes nothing but minus 2 by 3 1 upon 1 plus x square, and this becomes dx. So if I do this, our question becomes very simplified. It becomes x cubed by 3 log of 1 plus x square, and then it becomes minus 2 by 3. This 1 plus x square will get cancelled out. This integral becomes x cubed by 3 minus x, and then minus 2 by 3 tan inverse x plus c. So you can see that again by parts, and after by parts, little bit of what we learned earlier that we have to use and get to an answer. Now this question, what they're asking is, if this derivative of this function fx is nothing but log x, what is the value of fx? Now in order to do this, you will have to integrate this function. And if you do so, we'll have to also integrate this function. But if I integrate, you can see that there is no two terms. So this is a question based on invisible first part. So for first function we will take as nothing but again log x, the same thing that we did earlier. But the second function is nothing but 1 in this case. So I call this kind of question as nothing but invisible second function. The second function was not invisible, we took it to be 1. And now after this, the question becomes very simple, because you can apply by part. So it will become first function, that is log x, into integration of second function minus integration of differentiation of this. So it will become nothing but d by dx of log x. And once I've done that, there will be one more small part, that is nothing but integration of 1 dx. And from here we will be able to get our answer. So if I do so, let us see what answer am I getting. So if I do so, the first part becomes nothing but log x into x minus integration of 1 by x into x dx. So it simplifies to x log x minus x plus c. And if you look into the option, B option is correct. If I look into this next question, what it talks about is nothing but again invisible first function. So this is a 2019 question. What I can do is I can write this as 1 into sine inverse 2x dx. So this becomes my first function, this becomes my second function. So what I can write is first function, that is sine inverse 2x, to integration of second function minus integration of differentiation of sine inverse 2x into integration of dx. If I do so, this becomes x sine inverse 2x. This becomes nothing but 1 by root of 1 minus x. In place of x there is 2x, so let us write 2x whole square here. Differentiation of 2x would be 2. Integration of 1 will become x. Now what we can see here is whatever is in the denominator, that is 1 minus 2x whole square, we can put this as t. If I do so, the differentiation becomes nothing but minus 4x dx is equal to dt. And if I do it, it becomes x sine inverse 2x minus, this will become minus 1 by 2 dt by root t. And if this happens, what I can do is I can integrate it very simply. This becomes nothing but 1 by 2. Integration becomes t raised to the power minus 1 by 2 plus 1 by minus 1 by 2 plus 1. See, it is not a bad idea to write the formulas that you are using in the bracket below what you are writing the statement, because this will help you get that extra step marking. So now you can see that we have almost got our answer. In one step, we will be able to write it down. So if I write it down by putting the value of t, it becomes x sine inverse 2x. This 1 by 2 will get cancelled out, and this will become root t plus c. T was nothing but 1 minus 4x square. We can put it here. So this is the final answer. Now this kind of question I call as Deadpool, because Deadpool has a regenerative power in the comic series. So this is a kind of question that will regenerate itself. If you write it down, this is nothing but sec square x into sec x dx. So if I do it, this can be considered as second function and this can be considered as first function. And if I do so, then it becomes sec x integration of sec square x dx minus integration of differentiation of sec x into integration of sec square x dx. Now, once I have done that, you can see that the integration of sec square x is nothing but 10x. Integration of differentiation of sec x is nothing but sec x 10x. This part also becomes 10x. Now we have got here 10 square x, and we know that 10 square x can be written as nothing but sec square x minus 1. We are going to use this very simple identity of trigonometry. And if I do so, what am I getting? This is nothing but I. This becomes sec x 10x. And this part is nothing but sec of x into sec square x minus 1 dx. If I do this, it becomes sec x 10x. And this becomes sec cube x plus integration of sec x dx. We can see that we have again got the same integral from where we started, the same sec cube x. So this is what the question was. We have got the same integral again. So this is what I call as regeneration. This term has regenerated. So what I can do is I can write this again as nothing but I. Integration of sec x we all know is nothing but ln of sec x plus 10x. So if I take my I on the other side, it becomes nothing but 2 times I sec x 10x plus ln of sec x plus 10x का mod plus c. ठीक है. So if I divide it by 2, it becomes nothing but 1 by 2 of the same integral. This becomes our answer. Now this question is based on a very famous result The result goes like this. If you have e raised to the power x into fx plus f dash of x dx, it can directly be written as e raised to the power x fx plus c. The proof is based on by parts. This is a very famous identity that we can use here in this question. So directly the question is not in the form of identity. We'll have to first do substitution. So in this, if I put the value of x as nothing but e raised to the power t, dx will be equal to e raised to the power t dt. And if I put it down in the question, this part becomes t minus 3. This will become t raised to the power 4. And dx will become e raised to the power t dt. And after doing this substitution in the second part, now you can observe the concept. So this is nothing but first part can be written as t by t raised to the power 4 minus 3 by t raised to the power 4 dt. And if I write it down very simply, it becomes t raised to the power minus 3 minus 3 t raised to the power minus 4. Now, if you clearly observe this, what you will be able to see is the differentiation of this part is given here. So directly, we will be able to write the answer as nothing but e raised to the power t into the function. That is nothing but t raised to the power minus 3 plus c. There is direct application of this identity. If whatever function is given will come here, e raised to the power x will write here. Very simple, very elementary. Now, in the last step, just substitute the value of t. T was nothing but log x. So here if I put, this becomes x and log x raised to the power minus 3 plus c. Now next type of integrals are nothing but the ones those are based on the idea of partial fraction. Now partial fraction as a technique came from algebra. So it is basically an algebra question, and then what we have to do is integration, and usually this integration is on the lower side, not very difficult integral. So now let us take 5 cases to understand this. The first is if you have given two linear functions like x plus 1 into x plus 2 dx. So in this case, the first step that we are going to do is we are going to apply partial fractions. Now what partial fraction concept says is, we can write this as nothing but a by x plus 1 plus b by x plus 2. So whenever we have linear functions, we can write it in that manner. Now we can take LCM on right hand side, and it becomes a times x plus 2 plus b times x plus 1 by x plus 1 into x plus 2. So 1 becomes nothing but a times x plus 2 plus b into x plus 1. Now if I put x is equal to minus 1, I will be able to get the value of a on both the sides. If I put, it becomes x minus 1 plus 2. This will become b minus 1 plus 1. So 1 is equal to nothing but x into 1. So a. Let us write it as a. And the value of a from here comes out to be 1. Similarly, I can put the value of x. What I'm doing is I'm putting this as 0, as minus 2. And if I do so, it becomes 1 is equal to a into 0 plus b into minus 2 plus 1. So the value of b from here will come out to be nothing but minus 1. So we have figured out the value of a and b. Now this is the first part of the question. So what we have done in the first part of the question is, we have been able to break it down into two integral. So now let us write it down. So what we are saying is 1 upon x plus 1 into x plus 2 dx can be written as integration of a is 1 by x plus 1 dx, and then b, that is minus 1 upon x plus 2 dx. So this breaking down of an integral into two different integrals is known as partial fraction. Once I do this, in the next part, I'm going to integrate and get the answer. So the integration part is really simple. It will become mod of x plus 1 minus ln of mod of x plus 2 plus c. So answer becomes ln of x plus 1 by x plus 2 mod plus c. Now let us take another example based on the similar idea. So if sometimes it might be given that instead of this x plus 1 square is given. So in this case, the partial fraction would be written slightly different. In the a part, let us again do partial fraction. So if I write the partial fraction, whatever is the power, that many times that term will get repeated. So we will write a upon x plus 1, then again b upon x plus 1 whole square. Had it been x plus 1 whole cube, we'll write c upon x plus 1 whole cube, and then nothing but the third part, that is c by x plus 2. Once you have done that, the next part is quite simple. We'll take LCM, and this becomes a into x plus 1 into x plus 2 plus b into x plus 2 plus c into x plus 1 whole square by x plus 1 whole square into x plus 2. If I simplify it in the next step, 1 would be equal to nothing but a into x plus 1 into x plus 2 plus b into x plus 2 plus c into x plus 1 whole square. So once you have got this, let us find the value of ABC by putting values. So one obvious value of x in order to get the second term would be nothing but minus 1. So if I put x equal to minus 1, this term and this term will become 0. And what I will get is b into minus 1 plus 2. So the value of b comes out to be 1. In the next part, what we can do is we can put the value of x is nothing but minus 2. Now what we can see is this part and this part becomes 0. And what we are able to get is 1 is equal to c into minus 2 plus 1 whole square. So c becomes 1. And in the last part, now in order to find the value, what we have got is the value of a, we do not know. In order to find that, we can put some other value of x like 0. If you do so, 1 would be equal to a into 2 plus b into 2 plus c. Now this we are getting. Now let us put the value of b and c. So this becomes nothing but twice of a plus 2 plus 1. So the value of a comes out to be minus 1. Once we have got the value of ABC, question becomes very simple, because now in the second part, all we need to do is integration. So let us do that. So in the b part, what we will do is we'll write the same integral as nothing but a into integration. So now the value of a we should also write. Value of a becomes nothing but minus 1. So we'll write minus 1 by 1 upon x plus 1 x 1 upon x plus 1 dx. The second part, the value of b will become nothing but 1. So we can write this as plus 1 into dx by x plus 1 whole square. And then there is a c part that talks about the values again 1 dx by x plus 2. If I integrate this, the first part becomes nothing but minus of ln of x plus 1 mod. The second part would become nothing but x plus 1 raised to the power minus 2 plus 1 by minus 2 plus 1. And the third part would become nothing but ln of x plus 2 mod plus c. So you can see that it is very simple, very elementary. All we need to do is split it into partial fractions and then apply basic integration to get to an answer. Now moving forward, there is one more variation of the same problem of partial fraction. So now you can see that I have been given something like x plus 1 into x square plus x plus 1. But this quadratic that is given to us, this cannot be factorized. Now whether it can be factorized or not factorized, how can you check that? So you can take this x square plus x plus 1 and find its discriminant, that is nothing but the value of b square minus 4ac. So b square will become 1 square minus 4ac, and the answer becomes minus 3. This is the value that we are getting. Once you have done that, now once you figured out that this value is negative, it cannot be factorized. If it cannot be factorized, its partial fraction in the a part would be slightly different. So now instead of writing it as a, what we will have to do here is we will have to write it as, the first part is same, but in the second part we'll write it as bx plus c by x square plus x plus 1. Like this we'll write. And once you're written like this, again the next process remains same. We'll take LCM. And after taking LCM, let us compare like we did earlier, let us compare the numerators. If I compare the numerators, 1 is equal to a times x square plus x plus 1 plus bx plus c into x plus 1. Now a very simple way to find the value of a would be nothing but put this x plus 1 is 0. For that we'll put the value of x as minus 1. So this becomes 1. This is minus 1 whole square plus minus 1 plus 1, and this becomes 0. So you can see that this part will get cancelled out. So the value of a comes out to be 1. This is the first. Now in order to find the value of b, you can put some other value. So in this expression only, we can put the value of x as nothing but 0. If I put this as 0, what will happen? On the left hand side it is 1. On the right hand side we will have a 0 plus 0 plus 1. And then we have here, this will become 0 plus c. And this part will also become 1. The value of a is nothing but 1. So this becomes 1 plus c. So the value of c comes out to be 0. Now in the next part, what we can do here is basically, in order to find the value of c, put some other value. Let us put the next value is nothing but minus plus 1. We could have taken any value. I am taking it as 1. So if you take this value as 1, this becomes 1. This becomes 1 plus 1 plus 1. This will become b plus c. This will become 2. Now we know that c is equal to 0 and a is equal to 1. So this becomes 3. This becomes b plus c is 0, so b 2b. You can see that from here the value of b comes out to be minus 1. Once you have got these values, let us go back to the integral part. If I want to write the integral part, what I can do is I will be able to split this integral. So let us try and split this integral. So now this integral that we have written here can be written as a. A, we know that the value of a was nothing but 1 into 1 upon x plus 1 dx. And then bx plus c. So b came out to be minus 1. So this can be written as minus x by x square plus x plus 1 dx. We have got two integrals. Now this is very simple to find. Answer becomes ln of mod of x plus 1. And for the second part, now here I can write this integral as I dash and do it separately. Now here the same concept of quadratic that we did earlier will apply. We'll write numerator, the numerator part as nothing but d by dx of quadratic in the denominator plus c. And if I do so, this becomes 2x plus 1. Here there is a. And let us put this as again b. Let us use new nomenclature altogether because it can cause confusion. So let us use d here and e here. So there is a d here and then there is an e here. If I compare the coefficient, I can also substitute the value. I can also compare the coefficients. So let us write it in such a manner that it is possible to compare the coefficients. So the coefficient of x on both the sides, now we can see, will become nothing but minus 1 and 2d. So the value of d comes out to be minus 1 by 2. This is 1. And from the second part, we can see that d plus e will become 0. So the value of e comes out to be nothing but minus d or 1 by 2. Once you have got these values, in the next part, we can do integration and get to the answer. So let us do that. So now let us find the value in the c part of this I dash. So my I dash is nothing but minus x by x square plus x plus 1 dx. Now this numerator I have split into two parts. The first part is d into differentiation of denominator. So this is nothing but 2x plus 1 dx by x square plus x plus 1. and the second part is nothing but e times 1 upon x square plus x plus 1 dx. If I do this here, I can write my answer. The value of d also came out to be minus 1 by 2. So let us take this minus 1 by 2 common. This is 2x plus 1 by x square plus x plus 1 dx. And the value of e also came out to be 1 by 2. Integration of 1 upon x square plus x plus 1 dx. For the finding the first part, this part, it is very simple. We can put x square plus x plus 1 st. So this becomes twice of x plus 1 dx is equal to dt. So this becomes minus 1 by 2 integration of dt by t. And if I integrate this, this becomes minus 1 by 2 ln mod of t plus c. Let us also put the value of t. So ln of x square plus x plus 1 ka mod plus c. This is the answer of the first part. If I want to do the second part, that is this part, what can I do? In the second part, I will have to make a perfect square. So x square plus x plus 1. We can write this as x square plus 2 into x into 1 by 2 plus 1 by 4 minus 1 by 4. So this part can be written as nothing but x plus 1 by 2 whole square minus 1 by 4. And once I do that, this becomes nothing but 1 by 2 times integration of dx by x plus 1 by 2 whole square minus 1 by 2 whole square. Now we have a formula for integration of 1 upon x square minus a square dx, and that is nothing but 1 by 2a ln of x minus a by x plus a modulus plus c. Let us apply this formula. So this becomes 1 by 2 into 1 by 2a, that is again 1 by 2 ln of mod of x minus 1 by 2 by x plus 1 by 2 plus c. So we have got our answer. Now we can add both the answers and get the final answer. Now there is a fourth case to the same kind of problem. In this fourth case, what is happening is we have only even powers of x. So what we have is x square plus 1 by x square plus 2, and we cannot split this further. If there are only even powers involved, then in that case the partial fraction becomes simpler. So now instead of writing ax plus b, if there are only even powers, see, I am saying there is no odd power, there is no x term, there is no x cube term. So what I can do here is this splitting becomes easy. I can write like a linear expression only. So my answer becomes very simple. Now again I will do the same thing as I did earlier. So for the sake of partial fraction, now you can take x square as nothing but t for the sake of partial fraction. So this will become 1 by t plus 1, t plus 2. This becomes a upon t plus 1 plus b upon t plus 2. And if I write it, it becomes a into t plus 2 into b plus t plus 1. And the denominators will get cancelled out. Once we have done that, now in order to find the value, we'll put the value of t as minus 1 first. And if I do so, this becomes exactly like the first question that we did. Value of a came out to be 1. And in the second part, I can put the value of t as minus 2. And if I do so, this becomes b into minus 1. So the value of b comes out to be minus 1. This is exactly the first question that we did on partial fractions. Now once we have done this, in the next part, what I can do is, I can do the write the integral back. So the partial fraction from here came out to be in the b part. Let us write it down. So in the b part, the partial fraction came out to be nothing but 1 upon x square plus 1 into x square plus 2 can be written as a. A is nothing but 1 upon x square plus 1 and 1 upon x square plus 2. In this manner it had come. Now once you have done that, now if I integrate, it is nothing but dx by x square plus 1 into x square plus 2, and this will become integration of dx by x square plus 1 minus integration of dx by x square plus 2. Now this is directly formula based question. Answer for this first part comes out to be nothing but 1 by a. A in this case is nothing but, because this will become nothing but 1, tan inverse x by 1. And in this it becomes 1 by a, that is root 2 tan inverse x by root 2 plus c. If I look into this 2023 question that was asked in the exam, what you can do in this exam is, question is nothing but put x as nothing but t square. First remove this root sign. Always remember that whenever root signs are there, your policy, general policy will do something that removes that root sign or simplifies it in a certain manner. So this becomes dx is equal to 2t dt. And if this happens, this becomes a 2t dt by t, and this will become t plus 1. This will become t plus 2. And this reduces into the question that we just solved. This becomes nothing but 2 times integration of dt by t plus 1 into t plus 2. And this question we just solved when we started this topic. So in partial fractions, we have seen approximately exactly 4 cases, and those 4 cases were, if I summarize, the first was when we have something like 1 by linear expression 1, 2, 3, so on and so forth. The second was if I get some power of linear expression. The third was when I have linear expression into quadratic, and this quadratic cannot be factorized, d is smaller than 0. And the fourth was when there are even powers only. If you have these 4 cases in mind, largely speaking, any question of partial fraction you will be able to solve. Now, once we have done with this basic category or 3 important ideas in this chapter, that is substitution. Substitution was used in case of composite function, by parts that was used in case of multiplication, third partial fraction that was used in case of division. We now move on towards trigonometric integrals. In these trigonometric integrals, the core idea is, first you will have to apply some kind of a trigonometric ratio identity. Simplify and then integrate. Now for this integration, you will have to depend on one of the techniques. And this integration will either involve some kind of substitution or by parts or partial fraction that we just saw. Now for doing this first question, we are going to split this 2017 question into 2 different integrals. So if I just split this down, so it will become sine square x by sin x cos x dx. So you can see sin x gets cancelled out. In the second part, we can write it as cos square x by sin x cos x dx. Again, cos x gets cancelled out. So you can see the first part is coming out to be tan x dx. The second comes out to be cot x dx. And now we know the value of integral of tan x. We know, so integration of tan x is nothing but ln sec x mod, and this is nothing but ln sin x mod plus c. We can, if we want, we can simplify 1 or 2 steps more. Now if I look into this next question, that is splitting into standard integrals. And here again, in order to, when there is cos and cos, the standard technique to split this is take sine here and then write whatever is written here in subtraction. So we will write x minus a minus x minus b. Again, whenever there is cos or sine, in both of these cases we'll take sine in the numerator. If there is sine cos in the denominator, in that case we are going to take cos. This rule you should remember in solving such question. So if you do that, what is going to happen is this we can write as cos of x minus a into cos of x minus b dx. If I split it, this becomes sine of x minus a cos of x minus b minus cos of x minus a into sine of x minus b by cos of x minus a into cos of x minus b dx. By this will make our splitting very simple. If I do so, and one more thing we forgot was, when we are doing this, you can see that numerator, what is actually happening is these 2 terms are getting cancelled out. So we are left with sine of b minus a. So let us also divide by sine of b minus a. So that sine of b minus a will hang outside because it is a constant. So we can write this sine of b minus a outside. And this, if I split, the first part becomes nothing but sine of x minus a cos of x minus b by cos of x minus a cos of x minus b minus 1 upon sine of b minus a cos of x minus a cos of x minus b by cos of, and this was sine, cos of x minus a into cos of x minus b dx. Now you can see that in the first part this cos term is getting cancelled out here also. So we are left with nothing but 1 upon sine of b minus a, and this becomes tan of x minus a dx minus 1 upon sine b minus a, and this part becomes nothing but tan of x minus b dx. First part, we can take the sine of b minus a as common. This becomes ln of sec x minus a. This also becomes sec x minus b. Plus c. We can simplify further to get an answer. Now this 2018 question is based on basic manipulation and basic identity. So in this question, if I put cos 2x as nothing but 1 minus 2 sine square x, this question will get solved because in numerator we will have 1 minus 2 sine square x, and then we have 2 sine square x divided by cos square x. So we can see that this terms will get cancelled out, and as a result what is left is 1 by cos square x dx. That can be written as nothing but integration of sec square x dx, and that becomes nothing but tan x plus c. Extremely simple question based on simple identity. And now if you look into this 2023 question, you should realize that these basic formulas like cos 2x is equal to 1 minus 2 sine square x and 2 cos square x minus 1 are very useful in solving questions. Like if you put this in the numerator, this becomes a 2 minus 4 sine square x minus 1 divided by 1 plus 2 sine x. And now if I just simplify it, this becomes 1 minus 4 sine square x by 1 plus 2 sine x dx. And now in the next step, it is very simple. I can write, apply the formula of a square minus b square in the numerator. It becomes a minus b into a plus b. So we can write the numerator as 1 minus 2 sine x into 1 plus 2 sine x dx. And then in the denominator, what we have is nothing but again 1 plus 2 sine x. So this term will get cancelled out, and what we are left with is nothing but 1 minus 2 sine x dx. Now this can be split into two simple null integrals. One is dx, and other one is 2 sine x dx. So the answer to the first one comes out to be x. The answer to the second one comes out to be plus cos minus cos x. The answer becomes x plus 2 cos x plus c. That is nothing but option B. Extremely simple question. Now in this question, if I just put sin x equal to t, this is one such question that will simplify into partial fractions. If I do this, this becomes cos x dx is equal to dt. And the numerator will become 2 times dt. The denominator becomes nothing but 1 minus t and 1 plus t square. After that, now what we have to do is to solve it like a partial fraction. So we'll take this numerator, that is 2 upon 1 minus t into 1 plus t square, and write it as nothing but a upon 1 minus t plus b upon 1 plus t square. Now as we do in partial fractions, we'll have to take LCM, and if I do so, on the left hand side it is fine, but on the right hand side I get a into 1 plus t square plus b into 1 minus t divided by 1 minus t into 1 plus t square. Now this denominator will get cancelled out, and 2 will be equal to a times 1 plus t square plus b times 1 minus t. Now in order to solve this, what we can do is we can substitute two values of t. So let us take the value of t as 1 first. If I do so, my left hand side becomes 2 only, but the right hand side becomes a into 2 plus 0. So the value of a from here comes out to be 1. Now if I look into the right hand side, again one more value that I can put is t is equal to 0. And if I do so, 2 will become a plus b. We know that the value of a is equal to 1, so the value of b also comes out to be 1. Once we have got both of these values, now we can rewrite the integral that is given to us in the form of two simple integrals. So we can write it as nothing but a, that was 1, into 1 minus t by 1 minus t dt, and then b into 1 upon 1 plus t square dt. The answer of the first part becomes ln of 1 minus t mod by minus 1, and the second part becomes nothing but tan inverse of t plus c. Now, in order to write the last step, we'll resubstitute the value of t as sin x. And if I do so, I get my final answer. Minus ln 1 minus sin x modulus plus tan inverse sin x plus c. Now, this next question is again based on the idea of partial fractions. So what I can do in this question is, this is cos x, that is fine. The denominator can be written as nothing but 3 sin x minus 4 sin cube x dx. So as a result, what we can do is we can put sin x is equal to t. And with this substitution, what we get is cos x dx is equal to dt. So this becomes dt. And this becomes nothing but 3t minus 4t cube. And once we are able to do that, now what we can write here is nothing but the denominator can be written as t into 3 minus 4t square. And this we can do. Once we have done this, now this has become a partial fraction. Why? Because this denominator can be split into 3 parts. This is t, and this can also be factorized. We can take this 1 by 4 common. So this will become 3 by 4 minus t square. And if this happens, this can be written as 1 by 4 integration of dt by t. This becomes root 3 by 2 minus t, and then root 3 by 2 plus t. You can see that now this question becomes a question of partial fraction. Like we solved the question before that, similar way it can also be solved. Now this 2015 question is again similar kind of question, but a slight difference. What we can do in this question is again write this part as sin x is fine. Cos sin 2x can be written as 2 sin x cos x. We can take sin x common, and if we do so, it is nothing but 1 plus 2 cos x. In such questions, now you can see that directly we cannot see it as partial fractions, but after substitution it will be very visible. So what we can do is we can put cos x is equal to t. And if we do so, this becomes minus sin x dx is equal to dt. And if we put the value from here, you can see that this will become minus of dt. Sin x will come below. It will become sin square x, and this is 1 plus 2 cos. Cos x we have already put as nothing but t. Now this variable also needs to be taken care of, because when we are integrating, it is very important that every function that is involved needs to be in the same variable terms only. So if I move forward, what I first should do is I should substitute this. And this mistake a lot of students do, they will integrate and now they will take dx as common, sin square x as common. Now this is not possible, because this is a variable that will change with t. So we need to first write it down into the terms of only one variable, and it is a very significant and important statement. Once I do so, you can see that this becomes minus dt by 1 minus t square 1 plus 2t. And now this question has become a question of partial fractions: 1 minus t, 1 plus t, and 1 plus 2t. I hope you will be able to apply partial fractions after that and get an answer. Now this next question is a very interesting question. In this question, you can see that denominator sin raised to the power 4x, cos raised to the power 4x is given, and as I have told that every kind of trigonometric integral will involve some identity used in the starting. Then it will get converted into either a substitution, by parts, or partial fraction, or we can split it. This is also possible. And after that we are going to solve and get an answer. This is going to be the thinking process behind all such questions. So first apply identity here. So if I take this sine raised to the power 4x plus cos raised to the power 4x, this can be written as nothing but sine square x plus cos square x whole square minus 2 sine square x cos square x. And if I do so, you can see that this part will become 1. This is 1 minus 2 sine square x cos square x. And this is something very significant because once we have done that, we can write this as nothing but dx by 1 minus 2 sine square x cos square x. And now we can divide numerator and denominator by cos raised to the power 4x. So this will become 1 by cos raised to the power 4x. And this will become sine raised square x cos square x by cos raised to the power 4x. And once we have done that, something very significant comes out of whole of these. And that is nothing but, if you carefully observe, we have got a sec square x here. Sec raised to the power 4x here. And in the denominator also, this has become sec raised to the power 4x. And then what we have is nothing but minus 2 tan square x. Because 1 cos square x got cancelled. Now once I have this, what I can do is I can put tan x as t. And also this sec raised to the power 4 that we have, this can be written as 1 plus tan square x ka whole square. So if I do both of these things, first let us differentiate this as well. So the differentiation of tan x becomes nothing but sec square x dx is equal to dt. And now if I put the values in the integral that is above, it becomes nothing but 1 sec square x will remain. And then this will become dt. And in denominator, this part can be written as 1 plus t square whole square minus 2t square. This is what we are getting. Now let us simplify and see what happens. This sec square x can now again be written as nothing but 1 plus tan square x and hence 1 plus t square. And denominator, we can again open this. So this becomes t raised to the power 4 plus 1 plus 2t square minus 2t square. So this is getting cancelled. So now what we have got is an integral that looks like this. 1 plus t square by 1 plus t raised to the power 4 dt. And now in order to solve this integral, there is a method. The method goes like this. So this was my first step. This is my second step. And in the third step, I am doing one more very significant thing. So what I will do here is, I will divide it by t square. So if I do so, this becomes 1 by t square plus 1 dt. And denominator, it becomes 1 by t square plus t square. Now what we can do in here is basically, let me show you. It will give you a better idea. So this can be written as t minus 1 by t whole square plus 2. Now this we can do. And what is the benefit of doing so? This you will realize in a minute. So once I have done this, I can write this as nothing but 1 plus 1 by t square dt. This is the numerator. Denominator becomes a t minus 1 by t whole square plus 2. And now here we can put t minus 1 by t as v. And this substitution will help us solve the question, because once you do that, now you can see that derivative of this becomes 1 plus 1 by t square dt. That is something given in denominator, and then dv. So this becomes nothing but dv, and this becomes nothing but t square plus 2. And this integral you already know. The value of this integral is nothing but 1 by a tan inverse x by a, or in this case dy. Now we'll have to resubstitute the values. This will become v. This will also become v. Now we can resubstitute the values and get the answer. So if I do my first resubstitution, this becomes tan inverse t minus 1 by t by root 2. And then if you look into this question, the t part that we earlier substituted, was nothing but 10x. So let us also put 10x here and get our final answer. So this becomes 1 by root 2, 10 inverse. 10x minus 1 by 10x by root 2 plus c. Now let us move towards the last problem type, that is nothing but integration of irrational functions. So if I take this kind of question, what we need to do in such questions is, you can see that in this denominator, there is one x on whose power we have 1 by 2, another x on whose power we have 1 by 3. So you have 1, 2 and 3 in the denominator of this root. So what you will do is, you will take LCM of this 2 and 3. LCM of this will become 6. Again, what I'm saying is, here we have 1 by root 2. In the second part, what we have is nothing but 1 by 3. So I'm taking the LCM of this 2 and 3, that is in the denominator in the power, that is 6. Once you have got this, what you can put is x is equal to t raised to the power 6. Why are we doing this? Because our goal is to remove this root sign. So this is what we have got. So once you have got it, you can write this as 6 times t raised to the power 5 dt. This becomes t cube, this becomes t square. And now if I simplify this, this becomes 1t square will get cancelled out. So this will become t raised to the power 3 dt. This will become t plus 1. Now I have already told you, whenever the power of numerator is more than denominator, you need to divide that. So t cube will be divided by t plus 1. So this becomes nothing but t square. This will become t cube plus t square minus becomes minus t square. Then minus t becomes minus t square minus t plus. So this becomes t, and here you can write now plus 1. So t plus 1 minus, you get minus 1. Once you have divided it, the integral has become very simple, because now this integral 6 we can write outside. You can see that can be written as t cube minus t plus 1 into t plus 1 minus 1 by t plus 1. And if you do that, you can get two integrals. The first part becomes t cube minus t plus 1 dt, and the second becomes integration of 1 upon t plus 1 dt. Both the integrals can very easily be integrated, and if I do so, becomes 6 times t raised to the power 4 by 4 minus 6 times t square by 2 plus 6t, and the second part becomes ln of t plus 1 mod plus c. Once you do that, all you need to do is resubstitute the value of t. If I put t is equal to x raised to the power 1 by 6 again, I should get my answer. So you can see that such question involves removing the root sign. If you are able to remove that root sign, you will get your answer. In this video, we went in detail and understood the 7 types of problems that are usually based on integrals. Integrals, it is very important not just to know the concept, but to know the technique to solve problem, and most of the students get stuck there. I hope this video helped you a lot. In the next video, we are going to discuss the same kind of analysis for definite integrals. If you like this video, you will also like Pragbee's unique approach to teaching students or guiding students for the last mile journey. So if you are a student who has been preparing for 2 years and going to write this exam in 2024, this is one of the best ways and platforms that you can prepare with. Unlike other crash courses who focus on teaching 100% syllabus in just 2 to 3 months, which a student took 2 years to prepare, we have a different way to approach the problem. This process works on 3 very specific steps. In step 1, we start from you. What exact preparation have you done in the last 2 years, last 1 year, last few months? And what is the minimum amount of effort, areas, concepts and problems that required to be prepared to get a very good college from JEE Mains? In step 2, based on this customized plan that was prepared based on your strengths and weaknesses and the minimum path of least resistance that you can take to get into a very good college, we align you a one-on-one faculty, a faculty who is going to teach you as a student, keeping your needs into mind, where you are getting stuck in a topic, what kind of problems you cannot solve, and how to solve those problems in a very efficient and smart manner and convert that topic into tangible marks in JEE Mains. In step 3, we attach you to a test series, a testing platform where you can test yourself for each and every topic that you're preparing. You can write full syllabus tests and get an understanding that how this program is working for you, wherein the faculties can again sit with you and customize the plan based on your needs so that your score is getting maximized in JEE Mains exam. Using this program, Ashish was able to maximize his score in JEE Mains and JEE Advanced and was able to get into IIT Madras Mechanical in just a matter of 3 months.
If you are one of those students who think that he has got the potential, who can make it, and he wants to have a smart and efficient approach at this point of time, which can maximize his or her result in JEE Maths exam, you can apply for this program in the link given in the description, and somebody from my team will get in touch with you and help you out. See you until next one.